Okay, so a little bit about rendering techniques and the technology behind it, just to kind of go along with what we're doing in lab, help you understand a little bit about things that are happening that I don't really kind of elaborate while we're going through the project. One of these first terms I want you to really learn and hang on to is this idea of anti-aliasing. Um, because we represent our lines on a digital screen, each one of our screens are made up of all these fine pixels. I'll give a little more presentation about the pixelation of our screen later on. But I want to introduce this term of anti-aliasing. We actually have a selection of it in our graphic display options, and I'll tell you to turn it on many times. Smoothing the lines with anti-aliasing. And that's because this graphic over here kind of really well describes what that function does, that anti-aliased lines are. So you can see that if we have a line that's perfectly vertical or perfectly horizontal, it looks nice and crisp and sharp. But when our lines go on angles, we actually see the bump between each pixel. So this is a series of pixels lining up, and then in order to make the line go up, it has to actually jump into another set of pixels. And that creates these kind of jaggy lines that make our images look like they're not really sharp. And so anti-aliasing is a technique to add extra pixels around the line in order to make this kind of a sharpness to it, or an apparent sharpness to it. And it can really enhance, especially in architecture, because we're so concerned about making crisp straight lines in our architecture. This anti-aliasing can really help in the appearance of our buildings and our models. So keep in mind this term anti-aliasing. Another term that we start to use is the concept of ray tracing rendering. And usually when you hear the concept of ray tracing, it indicates that it's a higher quality of rendering. And that's because ray traced renderings actually not only look at the light coming off the object, but the light that's being reflected around off of other objects. And so really the best way to give you an example of this idea of ray tracing is this is not reality. These are just computer-made objects, glassware in a model. And you'll notice with ray tracing on, we're actually getting the reflections of objects in other objects. So the light that comes off of this object hits a glass surface, and it creates even the optical distortion, the highlighting. So this creates a huge sense of realism in the quality of our scenes. And because in architecture we have glass, we have metal, there's all kinds of reasons why this kind of ray tracing and light and the play of shadows, all reasons why this ray tracing of our graphics and when we render them really is important for creating that kind of realism. And so I've done a little bit of an experiment here of this idea of ray tracing versus conventional rendering. And at first go, you might say, well, these are pretty much the same. And then I would ask you to look a little bit deeper at what's going on here. So on the left, we have a conventional rendering. This is the rendering button that we have at the bottom of Revit. And you'll notice it's done a nice job. I placed a tree in front. I have these ballards here, which are actually covered with metal. And because they're covered with chrome and we're not ray tracing it, they're appearing as black. So if you'll notice over here, the ballards now their material is expressed as chrome, and you can see the reflections of objects that are around it, reflecting back off of it. Notice the quality of the shadow on the interior space over the concrete here. Notice the reflection I've placed another tree down this other walkway over here, and you'll see that there's a reflection of that in the glass here. So we get much more realistic appreciation for reflectivity on the surfaces of the glass. Even the idea of this looks like the glass is clouded over, and yet we still hear, because we see these subtle reflections of objects. So you can see this little reflection of a secondary reflection of a tree that's planted out there. You realize that these are glass surfaces, and we haven't had to resort to this kind of cloudiness to indicate glass. So we get this really sense of, as you look in here, of depth that's going on. So there's a lot of reasons why ray tracing really enhances this kind of realism in our drawings. So keep in mind the importance of that. If it was to bounce out to Revit really quickly, just to make sure that I reinforce where you're going to find these kind of functionalities. If we were to go to View, and let me make sure I'm on the right screen here. If we go to View, there will be a render with a teapot. Render in the cloud is the same thing, but if I go to Render here, and I'll do it very quickly just to show you what we're talking about. I'll just do a quick render. It won't be of great quality, but I'm going to render that using that teapot. It's going to go out now and spend some time There it is. It quickly re-rendered that scene for us. And you'll notice that this is almost the lowest quality of rendering, and how beautiful it portrays light and shadow. So once again, that idea of ray traced rendering, the teapot up here. The teapot is a reference to the first objects that people who were doing renderings on computers were using. That object had that curviness to it and that idea of it being a glossy surface in order to test the quality of rendering in the early years of computer development. So I'm just trying to get back over to the other screen here. Let me close that off and we'll get back to our presentation. So that's ray tracing. And I'm just reinforcing that in this graphic here. That's where you find it. And then here's a layout of a sheet and the difference between a presentation sheet conventionally rendered, and I just ran it again, showing you what it would look like if it was ray traced. So you can see these nice highlightings that are happening in here, a little bit of more richness in the glass. It really is up to you on kind of like this idea of the quality of the rendering that you would want to do. I don't consider this a necessity. I'm really just showing you the kind of examples. One of the problems with ray traced renderings is that if you change the model, the ray traced rendering won't automatically update because it's bitmapped already. So that's already a bottleneck, as we've discussed previously in this lecture, to kind of workflow. So there are many times where this rendering is fine because it happens quick and seamlessly. Just for your own knowledge, just comparisons between ray traced and conventionally rendered. You'll notice the extra detail in the brick, the better contrast and sharpness in the wood details, and mostly what I see are these nice highlights that are happening on the mullions of our glazing system. This is just a tip from the Revit kid that I thought was very useful. Keep in mind, we're always looking for these ideas of suggesting lighting settings. So if you're doing an in-session lighting setup and you want to have it look pretty good from the get-go, you might want to think of these ratios of 70, 50, and 20. The idea of 70 sun, 50 for ambient light, and 20 for shadows. I'm always encouraging to find better textures than what you'll find with inside of Revit, although Revit is getting much better at having inherent or encapsulated textures within the software. But there are plenty of sites where you can go and gather really rich, realistic textures. Just a reminder of that. A little more on this technology. In previous years, I've asked you to export JPEGs and PNG files. And this year, we're able to use PDFs because Revit has now a fairly functional PDF exporter that doesn't require the Adobe plugin. But I do want to cover this idea of JPEG and PNG files. I want to cover a little bit more about all this technology in the next lecture, but both of these are what are called compression algorithms. They are ways to reduce file sizes, and they have their good points and their bad points. Typically, we're mostly always dealing in photography with our photos that we share with each other in JPEG compression algorithms. So they'll take a file that might be 5 megabytes and make it 1 megabyte. But we have another compression algorithm that's called the PNG Portable Network Graphics. The JPG stands for, I think, Journalistic Photographers Group, and really not important that you actually know what those acronyms are. But the PNG format has some kind of unique features to it that benefit us as architects. PNG does a better job of representing lines looking sharper. So if we have mullions, railing lines, all the fine details that we might have in our architectural model, a PNG file will usually look better. So Portable Network Graphics is the acronym for these PNG files. One of the really important things to understand about a PNG file and why you might want to use it is this concept of transparency. It has what is called an alpha channel, a channel that understands that there is nothing in the scene behind whatever a given image is. And I'll have an example of that shortly. We're going to experiment with some rendering techniques in our project. If you're having problems with your rendering, don't really sweat it too much, but you should be able to do this kind of sketchy layout of rendering. And I kind of discussed with you, there's times when you want to make a presentation that looks more, I guess, sketch-like or preliminary, where we don't add materiality. Our lines aren't as, they're sketchy or wavy, as if we're not completely certain that something's going to exist here or not. We're just laying out ideas. And then we want to move into more formal, more complete kinds of presentations. I don't think I have. I'm missing the one concept of the PNG files. It's not to worry. We're going to come back to that in the next presentation because I'm going to build on that. I'm going to close off this lecture just kind of describing some of the ideas as I've already started here. In this one, we're going to look at rendering techniques, but we're also going to do, in this module coming up that's associated with this lecture, we're going to be doing some technical drawings also. We're going to make some rich, we're going to take a cross-section through a building and then pull up some nice details so that we can start making some evaluations of the way our elements connect with the wall and with the other surfaces. And I really want to make a big point that this week's project is going to be, or this module's project, if we're on a summer school program or whatever it is that are working online, also that the associated module that we're going to do is going to require the submittal of 4 separate sheets. So we're going to have 2 different rendering styles, and we're going to have 2 technical sheets that come along with it. And if you're having problems with rendering quality, this can be consistent colors if it needs to be. But I have my fingers crossed that you won't have any problems with rendering. This is just a couple, another architect's view of kind of the love of drawings. I saw this last year, and I thought it was really a really beautiful video of an architect who really does a really high quality.
When most people think about a set of custom house plans,
these kind
they're
of
probably
documents.
thinking about just drawings.
I'll stop
A drawing
this here,
set is a way for us to order and organize information, but
the
it's
connection
not
I
the
want to
only
make here
means
for
we
you
have
is
for doing
that,
that. So I want to
let me
walk
try and
through
back
all the
this up.
documents.
We're going to start in this module making technical drawings, and it might be interesting to look at somebody who really takes a lot of care and concern about making these technical documents. So this is hyperlinked for you to go to it. If you open up the slides on Blackboard and click on this link, it'll take you right to it. And I think it's well worth your time if you're passionate about becoming an architect. It's a great video. So, and this week we have our in-class assignment, which will happen right after a lecture if we're in person. We're going to do an evaluation of lighting. We're going to look at the idea of making a quick model. Really easy to do, obviously, in our modeler now because we're experienced with it. Cut some openings in it. And we'll look at the power of the solar heliostat, the idea of being able to move the position of the sun during time of day and time of year. And then we can look at the play of light within our building. So I just want to get you introduced to that idea that we have a really powerful tool for doing interior lighting. And I think that wraps up this lecture for this module.